Question 8 from our test. It gives us a function f of x, 600x squared times e to the negative 0.012x. And we're supposed to, for f of x on x from 10 to 800, find the maximum and minimum. We're supposed to do it by using calculus. Now we're all aware we can graph this thing and find its max and mins. And we'll do that to check our answer, but we're going to use calculus first. Now let's review the notion of the critical points. The critical points are the ones that, in a sense, could be the max or min. And there are, of course, three types in here. The derivative equals 0, derivative undefined, and the endpoints. So two critical points we get immediately. In our set of critical points, our x values, we have 10 and 800. I wrote x for some reason, but what I meant is 10 and 800. The minimum and the maximum. They could be our max or min. So we've got those two. We have to check their f of x values, and we're going to do that. We'll make a little table here of our critical points and their values. It'll be easy to see which is the max and min. Now we obviously have to take the derivative to find either of these two. So let's go ahead and do that. F prime, and for some reason Word capitalizes my f at the beginning, so I'm not making a distinction of capital to little f right now. So f prime, the derivative, is going to be, well, let's just keep the 600 out of the way since it's a constant, and now I have x squared times e to something. So I have a product here. So I'm going to have the derivative of one times the other without a derivative plus the reverse combination, x squared times e to the negative 0.012x prime. 600 times all that, so I put a bracket around the entire thing. So reviewing, the rule I'm using there is when you have two things, fg prime, f times g prime is f prime g plus fg prime. Our product rule for derivatives, you can review that from a previous video. So let's go ahead and do these individual pieces. 600, the derivative of x squared, of course, is 2x, e to the negative 0.012x, plus, and the derivative of e to ax, the a comes out in front, so not plus, minus 0.012. We'll leave the x squared here, e to the negative 0.012x. So we've got all our pieces. The x squared's there, and I simply move the constant in front because we're more used to seeing it that way. Now we're taking this derivative in order to find where it would be 0, because we get critical points there, and it's not undefined anywhere, it doesn't look like, so that's not going to be an issue. So we're going to set the derivative equal to 0. And we have a lot of things multiplied here. And it's easier to see answers if we factor it a little bit. So I notice in both of these terms a couple of things. I can factor out an x, and I can factor out e to the negative 0.012x, because it's in both terms. And what's left? Well, if I take an x out, it's gone. If I take e to the negative 0.012x out, it's gone, and I'm left with a 2. Minus, I take an x out of x squared, I'm left with an x. Take the e to the negative 0.012x out, it's gone. And I'm left with minus 0.012x. So I've got a bunch of factors, and we want them equal to 0. Now the only way factors, a times b times c, individual factors can equal 0, is somebody has to equal 0. No other combinations make 0, so that's why we like it factored. 600, that factor is never going to be 0. It's not a problem. X can be 0. It's 0 when x equals 0. So there's a solution to f prime equals 0. However, x equals 0 is not in between 10 and 800, so it's not of concern for our maximization here. Then we have the factor e to the negative 0.012x. This is a decreasing item. It has a decay rate of 1.2% continuously, and whatever it does, it goes down towards 0, but it never reaches 0. Remember what e to the negative looks like? E to the negative ax looks like that. So it never gets to 0, therefore it never gives us a 0, leaving us with this one equation over here, this one factor. 2 minus 0.012x can equal 0. And in fact, we would get negative 0.012x equals negative 2, and divide by negative 0.012 on both sides. And we get x is equal to whatever that comes out to. So let's turn on the calculator. I already had it in there. Negative 2 divided by negative 0.012, 166 2/3. 0.6 forever. So that is a new critical point. 166.66 forever. We'll maybe round that off to 67. So we need to find the f values for all three of those. Now the quickest way to do that is going to be to graph the thing, which I've already typed it in, 600x squared times and so on. And I believe I've already picked a reasonable window. 0 to 1,000 strikes me as reasonable because I want to see 10 to 800. So I graph, and the graph looks like this. So we could obviously find the max on the calculator as well. And I'm just going to do second calculate value very quickly to see what the value is at x equals 10. And I get a, what is it, a 53,215. Writing on top of itself, 26,000.
0.07, it looks like. It's kind of written on the graph, so I might want to check that one in another method. Then I'm going to check 166.67, and I get 20. Oh wow, a big number here. 2,225,000. And it's also putting the x right up there, which is good news. It's right on the maximum on our picture as well. So not 225, 255. .588.1. So we found our maximum is at x is 166.67. We've also found our minimum. Looks like it's going to be 800. Looks like it's actually come down lower out here. To see that better, I might want to change my Y scale a bit so I can push this thing up just a little bit. Maybe we'll make Y min. Yeah, it's a pretty big scale there. Let's see if that helps. Now I might have some room to actually read these a little better. So, and you can improve that, make sure we've read these numbers properly. But we've got the maximum, and we've also found the minimum in this set of critical points.